take a look at how to solve this logarithmic equation. As you can see, this differs from some other examples that we've looked at because I see multiple logarithms in this problem. So taking a look at this, first off, I see that I have log of x minus 3 plus log of x plus 3. This plus 3 is not contained within this logarithm. It would have needed to be in parentheses like this one for it to be intended for it to be that way. In this case, it isn't. So the first thing we're going to need to have do here is actually get rid of this plus 3 by subtracting it from both sides to get to this point where I have log of x minus 3 plus log of x. Again, subtract 3 on both sides. That would make this equal to 1. Before I go too much further with this problem, I kind of want to comment on the domain again of the logarithmic function. Remember, I can only evaluate these logarithms for values greater than 0. So for x would have to be greater than 0 to be able to be plugged into this logarithm. But this one actually is a little bit more specific than that. X would actually have to be greater than 3 to be able to be plugged into here and end up with something that wasn't negative or wasn't 0 like that. So we need to keep that in mind as we're working with this problem, that our solutions that we get have to be greater than 3. If we get anything that's not greater than 3, we have to toss it out because it wouldn't make the original equation true, because a part of the equation, or one or more parts of the equation, would be undefined. So let's just keep that thought in the back of our head. X has to be greater than 3 for this particular problem because of what's inside this logarithm. So now, how do we continue from here? Because in the other example, we converted to exponential form and then we solved from there. But we have multiple logarithms. So before we can try to convert to exponential form, we have to use our properties of logarithms to go ahead and condense these two logarithms back into a single logarithm. And we had that product property that told us how to do so. So this should be able to become log of the product of these two pieces. So whenever I multiply the x minus 3 times the x, that would become x squared minus 3x, like that, is equal to 1. Now, at this point, I can convert to my exponential form. I don't see a base number written here. That means this is the common logarithm. The common logarithm has base 10. You must know that to be able to do this problem. So we're going to go 10 to the first power equals this algebraic expression. So I have 10 to the first equals x squared minus 3x, like so. 10 to the first is just 10, and then I'm going to go ahead and get this equal to 0. So I would have 0 equals x squared minus 3x, moving the 10 over here as well, I would have minus 10. So at this point, I need to go ahead and solve this and figure out my values of x. I see this as a quadratic equation, so you can call upon a variety of different methods that we've covered in the past on how to solve quadratic equations. I look at this and I say, this looks easily factorable to me. I can find two numbers that multiply to negative 10 that happen to add up to negative 3. That would be negative 5 and positive 2. So I'm going to go the factoring route, but you could certainly use the quadratic formula, graphing, completing the square, whatever other methods you wanted, whatever else you wanted to try to solve this quadratic equation. So factoring this, jump over here, I have 0 equals, that would become x minus 5 and x plus 2. Setting each of those factors equal to 0, I would get that x equals 5 from that factor, and I would get x equals negative 2 from this factor. So it looks like I have two solutions to this. However, one of these is extraneous. It's not actually a solution. It does not satisfy the original equation. Remember what we talked about before. X had to be greater than 3 or else this logarithm would be undefined. Actually, both of these would be undefined. No, this one would be undefined if it was greater than 3. This one had to be greater than 0. So but just saying it had to be greater than 3 covers all bases there. So knowing that x has to be greater than 3, I know that x cannot be negative 2, and therefore the only solution to this logarithmic equation is x being equal to 5. Hopefully I didn't stumble and misspeak and confuse you anywhere in there with that. But again, knowing from our condition we talked about back here, x having to be greater than 3 throws out this condition, solution of negative 2 as extraneous. So x equals 5.